Welcome to Easy Learn. This is Introduction to Electronics Season 3 Episode 1 English. I will give the introduction about the terms used in the electronics in this series precisely. Today I will discuss the following topics: introduction, input transducers, output transducers, electrostatics. Okay, in introduction, the electric charges and current is the base of the electronics, like the blood in the human body. So the research has found different application. For example, the car ignition, electric ignitions, and in home, dimmers, washing machines, mobile phone, TVs, etc. There are a lot of the applications. Just some applications. In fact, if you look anywhere in home, in industry, you will see a lot of applications of electronics. So it's a very important. So the base of the electronics is basically the electric charges and currents. This is another application often found in the ceilings, the burglar, smoke and fire alarm in the banks, in the industries, which detect the smoke and fire and alarm. Okay, next slide. An electronic circuit, even a simple one circuit, any simple one circuit, is often made from a large number of the components that are joined together. For example, in this slide, if a simple one, we take a CFL energy saver bulb. It's a simple light, but behind this there are a lot of the components involved. It seemed too complex to understand its working at a first glance. However, all that is required to build many simple devices is a clear idea of what the inputs to the system will be, the type of the output that is required. At each step, you are not asked to calculate the input or output, and at each for each component. For example, it makes a complex sense if you calculate each point. So what the manufacturers did, they basically grouped the components into blocks or sub-circuits, called the black box approach. Manufacturers divide different components in the blocks with respect to the particular function, according to their function. So it's easier for the troubleshooting. For example, if a circuit involves okay, I will discuss this example in the next slide. Okay, next slide. This is a picture in which a digital graph is converted into the analog graph, and with the help of a circuit, we don't know about what is inside this circuit, what are the components. We don't know the knowledge of the components involved. We just know its function, what this black box did. We know that it converts the digital graph into analog, so we just know its function. We just don't know the knowledge of its internal working. Okay, without any knowledge of its internal working, this implementation is opaque and it's oftenly called black box approach. Okay, so if we can divide this very simple typical system into a sense, or you can call input, and it is an output, and this is the black box. In the last slide you can see this is the black box. In other words, we can also say that it is a sense. Here is a deciding process or a processing unit, or here it is an act or action time. So here is an example of the system is a compact disk system. Okay, divided into the 5 groups. You can also divide this in 6 group or other groups. Many groups are lesser than in this diagram. I divide here in 5 major groups. For example, this is the first one: laser, detector, preamplifier, amplifier and speaker. This makes an easier for understanding, for learning, for troubleshooting. For example, if an error comes in the amplification process, here the output is not higher. For example, I required 100 volts and the amplified output is not, I am receiving not amplified output, so the speaker is not working well. So what I do here, I didn't open the laser system, I didn't go on the detector components. I just go precisely without wasting any time. I just focus on the amplifier system, and I focus on this. So this makes an easier in the troubleshooting. This makes easier for learning. And if this, first of all, this sketch is drawn, and after this is designing, next step is designing, and it's easier. Okay. Nowadays, many simple or single components are packed in the form of ICs, called mass-produced integrated ICs. So here you can see that these are ICs. They are easier to for understanding as well, and less complexity. You can see that, and looks also nice. And these are basically used basic components used to connect many of these boxes. These are black boxes. You can also say that this is one box, black box, and this is one black box, and this is one black box. Okay, next topic is the input transducers. There are two type of transducers. One is input transducers, and second one is the output transducers. Okay, first we will discuss the input transducers. An input transducer is a device which converts the any form of the signal into electrical signals. Because the processing units involve the electrical signals, computer understand electrical signals. So as I am speaking, my voice signals are converted into electrical signals by a device called transducers, and here it's a microphone. Okay, typical input signals might be a fluctuating a switch, pressing a keyboard, a digital signal, anyone, and heat, maybe anything. They are typical type of the input signal, any signal. But there are different types of the transducers. We can see here, you can see that physical quantity, and here is an input transducer, and the electrical signal. So this may be different each time, depend upon the physical quantity. For example, in my case, it's an microphone, and if I want to in the heat case, for this may be sensor called thermistor, or any other. It may be changed for each time. It may be same or different. It depends upon the scenario. Okay, the initial input device is called transducers. As I told, they convert the input into electrical energy or electrical signals for the next stage. This example I already told, and this is the same what I told you. Microphone. Okay, mechanical switches, the same. A switch allows a current to flow when the contact is made. Mechanical switch, like the switches in your room, and this is a toggle switch, an example of the mechanical switch. Okay, output transducer. Next topic is the output transducer. This is the process at your end when you are listening my voice. The first I told you, the microphone example is at my end, that I am recording this video with the help of microphone. This is the input transducer. You are listening the voice with the help of output transducers. Speaker is in your case the speaker is the output transducer, and the LCD is also an output transducer. Okay, the output transducer is a device which converts the electrical energy into the other form of energy. Other form may be many other forms, such as sound, mechanical, heat, or light. This is a diagram which shows you electrical signals. It is an output transducer into physical quantity. This is the example what I am telling you last time, that signal is a transducer. My voice signal, this is my mouth, and these are the voice signals. And there is a transducer. In my case, it's a microphone. Electrical signals, electrical processors, my computer, and here it is in the current and voltage form. And there is a transmitter. There is a transmitter, and these are the electromagnetic waves, and here amplitude modulations, by the way, using. Okay, it's a receiver, and in your case it may be electronic signals. Receiver receives this and convert it into electronic signals, and then transducers, maybe your microphone, your speaker, and then it's your ear which takes the signal, which receives the signal. Okay, it's an example. Loudspeaker and other noise generating devices. These devices mechanically vibrate the surrounding air, producing the sound. The same thing I already told you. And this is a process. Here a microphone is called the input device, and there is a controlling system. I already in the last slide we take it brief in the details. These are the different. Another example, lights are also LEDs that are used for the indication process, and the screens of the calculators. A laser might be another examples, like motors. The output current may operate a motor that converts the electrical energy into the mechanical energy, or magnets. The output current may create a magnetic field that can be used to provide the electromagnetic force, and many things like liquid crystal displays, LCDs, are also used, as you are watching this video on the LEDs. So okay, last topic is the electrostatics. In electrostatics, as the name indicates, that electrostatics is a study of the charges without motion. The motion is not involved in the electrostatics. So the charge objects exerts an electrical force on each other. The main thing here is I had also explained these all the terms of regarding electrostatics in Introduction to Electronics Season 1. So I also recommend you to watch for details Introduction to Electronics Season 1, as this is Season 3. So I will discuss here very shortly, because these are also already explained in Season 1. Okay, there are two types. When I talk about the types, there are two types. One is positive, everyone knows, and one is negative. But there are three states. When we talk about the states, there are three. One is positive state, this is the positive state, and the second one is the negative state, this is second, and third is the neutral. When we talk about the positive state, we can say this is the more positive than the negative charges. When we talk about the negative, we can say that it's more negative than the positive charges, while it's neutral. This it means that there are equal number of the positive charges and equal number of the negative charges. Electrons are negatively charged and protons are positively charged. Just for your everything, just very precisely we are discussing in deep details. The charge on each electron is 1.6 multiplied 10 raised to power minus 19 coulomb, and there is a sketch of these electrons, protons, and these are neutrons. These are positively charged protons, and neutrons carry no charge. So now next is the electrons are much lighter. The electrons are lighter than the protons and more easily moved in the conductors. That's why the electrons are used when the voltage or current is flowed. Electrons are the one which are used as the current, while protons doesn't flow. Electrons always makes a charge. Okay, most charged objects have many million of the positive and negative charges. Whenever there is even very small milliampere charge or very light charge, this may involve millions of the positive and negative charges. Exception for the single protons, ion and alpha particles are expections, and positively charged objects usually become charged by the removal of the electron. Whenever there an electron is eliminated, definitely a positive charge is increased. Protons are increased because protons didn't take part in the bondings. So I already explained, as I say in season 1 though. So whenever an electron is relieved from an atom, so the protons are automatically increased in size because electrons is decreased. So the as a whole net charge is positive charge is increased. So conductors allow charge, usually negative charges of electrons to flow. I already explained in last slide. This is the case because electrons are lighter and easily flown. So electrons always take part, and why they are lighter and why they are lighter and take part in the flow of the charge, because they are the outer shells and can take part in the bondings and chemical reactions, while the protons are in the inside and heavy particles, they didn't take part in these reactions. So electricity is the flow of electrons, so it's the flow of only electrons. Insulators that doesn't allow the current to flow. There are some examples of the insulators: plastic, rubber, glass. As you know, poles. These are the wires are hanged with the help of the glass or a wood poles, or these are the gloves used of clothing. Some insulators are less conductive than others. Semiconductors, that is most important. Diode and application is a series on this channel. You can also try this one. Semiconductor is very important and allow to current to flow under certain conditions. If this is the blessing of the semiconductors, there are a lot of the devices in as a mobile phone and other processors, computers, everything. I can say that if there is no semiconductors found, then these applications might not be searched right now. So in electrostatics, semiconductors are very important topic. Semiconductors, we change their property according to we required. So semiconductors are very important. Light, heat, magnetic and electric fields and impurities can affect. There is an example of diode as I am telling. So here comes an example. This is the positive terminal of the anode. This is the symbol we use in circuits, and this is the cathode side. This triangle this side of the triangle is positive, remember, and this line, where this line is, there is a line, this shows that cathode. So there is a diagram also. There is a band, the band shows the negative side, cathode, and here is the positive side. Further, there are shortly explained more terms. Electrostatics is study of the non-moving charges. I already explained in the previous slides. A force between charges attractive. The opposite charge, if they are two charges have opposite sign, definitely an attracting force. If there are similar charges, definitely there is a repelling force. Neutral objects can be attached to the charge object if the neutral objects become locally. If the neutral object doesn't have any attraction or repel force, if neutral object can only attract to another object, if neutral object is charged by some externally charged by and due by somewhere or some process, neutral atom, for example, there is a neutral atom and its an electron is leaved, then it becomes a then there is positive net charge is on this on the atom. So it's now changed from neutral to a positive charge, positive net charge. So now it attracts and repels from by the other charges. So these facts will be used in the study of the electronics. These are very basic concepts, just introduction. So the topic discussed in the next slides or next episode, resistors. I will discuss about series combination and parallel combination of the resistors and some types of the resistors. All the topics discussed will be again very precisely, and just summary will be explained. And at the end, I will say, if you like this, then share this to spread the knowledge in the easiest way. Watch, learn, grow. See